In this video, we're going to do a few more difficult SOH problems. To start out though, it's some kind of basic simple ones. This question says, use the diagram below or the triangle below to answer the questions. This wants me to write the sine of C, so it wants the sine of angle C. And so all I need to do for that is first I'll recognize my hypotenuse. Here's my right angle. Opposite from my right angle is my hypotenuse. Now for angle C, that's this angle right down over here. My adjacent is this side over here, the 15. My opposite is the 8 over here. So I'll put opposite, which is across from my angle C, and adjacent, which is right next to, but not my hypotenuse. And that's all it is, because we've got over here, we're using TOA because it wants the sine of angle C. I'm going to use SO, which is opposite, and opposite in this case is 8, over H, hypotenuse, 17. And so then the answer over here is simply 8 over 17. This isn't asking you to solve anything. It's not asking you to simplify. It's just saying write what the sine of C is equal to. And I know that sine is opposite over hypotenuse. So it's going to be from angle C, opposite 8, hypotenuse 17. Let's do these next two a bit quicker. This time I want the cosine of A. Notice that it's talking about angle A this time, which means I have new opposite and new adjacent. A is over here, so opposite from angle A is actually now the 15, so I can move my opposite down over there. Adjacent is right next to it, but not the hypotenuse, so here's my new adjacent. Cos uses CA because it has the C, cos for the C, and it has adjacent over hypotenuse. Well, now adjacent is over here, so now it's going to be, again, cos of A is now equal to 8 over 17. Interesting how sine of angle C is the same thing as cos of angle A. All right, finally, I'm going to do tangent of angle A. So this is now tan of A is equal to, I'm still using angle A, so my adjacent stays here, my opposite stays here. Hypotenuse never changes. Once I find that right angle, it's always the same. And tan has the T, so it's TOA. It's going to be opposite over adjacent. So it's going to be opposite 15 over 8 adjacent. 15 over 8. Okay, fantastic. Next, I want to find the measure of angle C. So again, I'm using angle C over here. My new opposite is back up over here by the 8. My adjacent is the 15 over here. To find the measure of angle C, I have all of these sides. I can use whatever I want. Because I have adjacent and opposite and hypotenuse, I can choose which one I like the most. You could do this with SO using opposite and hypotenuse. You can use this with cos using adjacent hypotenuse, or you can use it with TOA using opposite adjacent, because I have all of them. Don't let that decision freak you out. You're allowed to do whatever you want to choose. I'm going to choose, for this case, I'm going to choose SO. And so that means I've got sine of angle C is going to be opposite 8 over hypotenuse 17. 8 over 17. When I'm over here and I have the angle that I'm looking for inside of my sine, I have to do sine inverse. Sine inverse. Sine inverse. This sine inverse cancels the regular sine, and I just need to plug that in there because now I've just got C is equal to sine inverse of 8 over 17. And so let's pull out our calculator over, and I'm in degree mode. That's what the DEG is for. And I can just do inverse sine 8 over 17. You might notice it's saying arc sine. That's fine. That's just the inverse of sine. Inverse of 8 over 17 is 28.07. So I can say angle C is equal to 28.07 degrees. Uh-oh, it froze. Okay, next I want to find the measure of angle A. So angle A, the only difference here is I need to be careful about my opposite and my adjacent. Angle A, the adjacent is now back to 8. The opposite is over here because angle A is up here. We're not talking about angle C anymore. Here, I already used sine. I'm going to use cos. So this will be cos of A, which is going to be, cos is ka, so it'll be adjacent over hypotenuse, 8 over 17. You might be thinking this is the same as this question, except it's using the cos function, which is different from the sine function. Here, again, I have my angle inside of my cosine, so I need to do cos inverse. That cancels with that. And that means I also need to do cos inverse on the right side because of algebra. I'm then left with A is equal to cos inverse of 8 over 17. And if I clear my calculator and just do that again, inverse cos of 8 over 17, I find that my angle is 61.92. degrees. If I wanted to, I could have been clever. I could have just used sine or cosine here, and then I could have used angle algebra because 28.07 plus 90 plus what would get me 180, but instead I did it using sine. All right, let's do the final question, which is a little bit harder, but it's really not that crazy. It's just a little more SOH. First of all, let me move my calculator out of the way. Let's read it to start. In the accompanying diagram, the base of a 15-foot ladder, so here is my ladder, rests on the ground 4 feet from a 6-foot fence. So the base of my ladder is 4 feet away from this 6-foot fence. Okay? If the ladder touches the top of the fence, so that's just saying, the ladder is touching the top of the fence over there, and it also touches the side of the building over here, what angle to the nearest degree does the ladder make with the ground? So it's asking, here's the ladder, here's the ground. It wants to know this angle. I see 2 triangles here. I see a smaller triangle right over here, and then I see a bigger one made by the building and the ladder over here. For this one, I only have the 15-foot hypotenuse on the bigger triangle. I don't have anything else about the bigger triangle. But I do have 2 sides for my smaller triangle, 4 and 6, so I can use those to find the missing angle. So for this, my hypotenuse is over here. Adjacent is right next to it. Here's my adjacent. And opposite is my 6-foot. Opposite is right over here. Okay. I have opposite, I have adjacent. That means I'm going to use tan, uses opposite and adjacent. So I'm going to set up tan of my angle, I'll call it theta. This is not 0, by the way. This is another variable. Instead of using x, I use theta for angles. Tan of theta should equal opposite over adjacent. In this case, 6 over 4. 6 over 4. I'll do tan inverse, tan inverse, tan inverse. That cancels with that. And I'm left with my angle is equal to tan inverse of 6 over 4. Let's bring our calculator back over and take a look. Clear this. Inverse tan of 6 divided by 4, and I get 56.31 degrees. So the angle theta is equal to 56.31 degrees. All right, done with that part. Using the angle found in part A, determine how far the top of the ladder reaches up the side of the building to the nearest foot. So the top of my ladder is over here, and it wants to know how far up the ladder reaches on the side of the building. So it wants to know this missing side over here. We'll call that X. Okay, well, I have this angle in here. We just found that it was 56.31. I'm looking for the opposite, and I have the hypotenuse. So I am looking for the opposite. I have the hypotenuse. That means I'm going to be using sine from SO. All right, so I will set it up. Sine of 56.31 should equal opposite X over hypotenuse 15. This time my angle I do have, so I'm just going to do regular old algebra here. I'll multiply both sides by 15 to move that 15 over there, and I'm left with 15 sine 56.31 is equal to X. And once I've got the X all by itself, I can just plug this into my calculator again. So I will clear 15 times sine of 56.31, close parentheses. And I find that the missing side over here, this side of my building, is 12.48 feet tall. So I can say X is equal to 12.48 feet. All right, we're almost done. Finally, it wants to find the distance between the side of the building, and the fence. Now, if I look at the shape that makes, it's a quadrilateral, it's not a triangle. But I still do have that bigger triangle, and I have this 4 feet here. If I find this entire side and then take away 4, I'll figure out what's over there. So again, I have the 56 here. I now have 12.48, and I was given the 15. I can use either adjacent and hypotenuse or adjacent and opposite. We've already used tan, so let's use cos, because cos is CAH, cosine of adjacent over hypotenuse. So I'm going to do cos of y is equal to, sorry, it's not cos of y, because we know the angle is actually 56. It's cos of 56.31 is equal to adjacent y, we don't know it yet, over hypotenuse 15. Again, I made it nice and easy. I can just multiply by 15 on both sides. I'm using cos, so it is going to end up different than this because here I used sine. So I'll multiply both sides by 15. And I'm left with 15 times cos of 56.31 should equal y. If I plug this into my calculator, 15 times cos of 56.31, that's what we wanted, right? Yep. And that gets me that y is equal to 8.32 feet. But that's the entire distance. They wanted the distance between the side of the building and the fence, so I just need to remember to take away that 4 feet. So the answer is really going to be 8.32 minus 4, which is just 4.32 feet. And that is my final answer. I hope that was helpful. Yeah, good luck practicing more SOH.